Okay, today's lesson is a different approach to classification. We are going to be using the information that you guys figured out last week about classifying triangles by sides and angles in order to classify them, but now we're going to be using a coordinate plane. So at the top it says, use your knowledge of triangle classifications to solve the following problems. The coordinates for the vertices of triangle ABC are as follows. A, B, C, use the coordinate grid below to graph. So we need to graph point A, that is -2, 6. So again, remember this is X, this is Y, so this is your X-axis, this is your Y-axis. So we would go to -2 on X and then up 1, 2, 3, 4, 5, 6. Put a point and then we would label this A. B is 1, 2, 3, 0. So it would be right here. And then C is -3, so this way, and then down -5. 1, 2, 3, 4, 5. And this is C. And then you connect them like it said, A to B, B to C, and then A to C. So there's our triangle ABC. Then it says, based on your knowledge of angle classifications, what does this triangle appear to be? Again, this is angle classifications. So according to the angles, it kind of looks like either acute, right, or obtuse. So if you look at the picture, you can kind of decide that and then put your answer there. So do you think it's right, acute, or obtuse, and write your answer. Part B says, now find the slope of each segment of the triangle and then record your answers below. What you're looking for is to prove that this triangle is what you say it is. So to me, it looks like this may be a right angle. So I'm going to put that I think it might be a right triangle. So in order for it to be a right triangle, the slopes have to be negative reciprocals. What that means, or that you should already know, is that they are opposite flip. So let's say I get the slope 2/3. The negative reciprocal of that would be negative, and then 3/2. Okay? Or if I had 1/7 negative, then the negative reciprocal would be +7/1, which is +7. Okay, so we need to see if there's any negative reciprocals, because that means that the lines are perpendicular, which means that there's a 90-degree angle. So I'm just going to do one slope, and then you guys can do the other one. So I'm going to do the slope of, let's do AC. So I'm going to count from C up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then over 1. So the slope here is 11/1, which is just 11. So you need to find the slope of CB on your own and the slope of AB on your own, and then you need to see if it appears to have any negative reciprocals. Part C says, based on your knowledge of side classification, so now we're talking about the sides, what does it appear to be? So maybe AB is equal to BC. I mean, it kind of looks like it might be, but we're not sure. So I'm going to go ahead and put that I think it might be isosceles, but I could be wrong just because I'm going off of looks. Okay? So it says, now find the side length to verify that conjecture. And again, this is further on down. So I wrote isosceles. Okay? And then it says find the side lengths. So in order to find the side lengths, I have to use distance formula. So that was the square root of x2 minus x1 squared plus y2 minus y1 squared. And again, this is just x minus x and y minus y. So I'm going to do one of the sides for you, and then you can do the other two. So let's say I'm going to do the same one I did up here. I'll do AC. So what we need to remember is that A is the point -2, 6, and C is the point -3, -5. So if I'm going to do the distance formula, this right here, I'm going to subtract the x's and square it, subtract the y's and square it. So let's look. So parentheses, the two x values are -2 and -3. So it would be like this, and square it, plus parentheses, minus, and square it. So my first x value is -2. The second one is -3. Notice I do end up with a negative negative. Then I have the y values, so 6 minus -5. And this is fine to have. So what I'm going to do is I'm going to put this in my calculator exactly like it looks. So I'm just going to do the inside first. So parentheses, -2 minus -3, close parentheses, squared. Then plus parentheses, 6 minus -5, close parentheses, squared. And when I hit enter, I get 122. So AC should be the square root of 122, if I put that in correctly. So this is the square root of 122, and then we do the square root of 122 and hit enter, and it's approximately 11.05. Again, approximately is just wavy lines. So now you need to do the same thing, and I need you to find the side lengths for AB, and you can do your distance formula, and then you need to find CB and do your distance formula. Okay, and so then if any of them come out the same, you know they're equal. And so then it says classify triangle ABCs by angle and sides. So if you find negative reciprocals up here at the top, then that means it is right. If two of the sides come out the same, that means it is isosceles. Again, we went solely on looks, so that may or may not be true. Okay? All right, let's flip it over and go on a different page. So on the back, we're kind of doing the same thing. It says use the distance formula to classify the following triangles by sides. So you're going to do the same thing that we did on the first page for part D. So again, your example here is going to be part D from the front page. You're going to use that distance formula that I wrote down. Then 3, use your knowledge of slopes of lines to classify by angles. So again, remember you're looking for negative reciprocals. And again, that's exactly like part B, not number B, from the front. So let's go down to number 4. Number 4 says triangle ABC is isosceles. Remember, isosceles means that it has two sides that are the same with a vertex angle at A. The lengths are as follows: AB, BC, and AC. The vertex angle, vertex just means the angle that's at the top, is A, which has two sides, the legs of the isosceles, which two sides, I can't read, are the legs of the isosceles triangle. So the vertex angle, if that's A, the two isosceles, or the two sides that are the same, are always what would be connected to A. So it would be AC and AB. Again, they're always connected to the vertex angle, so it says, what does it mean about those legs? Well, if those are the two legs of an isosceles triangle, that means that AC is going to be congruent, remember that's the fancy word for equals that we use in geometry, to AB. So now it wants you to actually draw your triangle. Be sure to mark the side lengths using these x values. And then down here on part D, it says based on those two congruent sides, what two side lengths are going to be equal? That's the same question as part B. And then based on your answer to part D, write the equation that you would use, and then solve the equation. So we know which two sides are equal, so we should know which two equations up in the directions are equal. So you could go back up and you could figure that out. Okay? All right, let's flip to the very, very back page. And I will work one of these for you. We're going to go down to part B. Well, I guess I should read directions first. It says the following triangles are isosceles, again meaning JK is congruent to KL. Solve for X. Then determine if the triangle is equilateral by substituting the values into the other side lengths. The figures may not be drawn to scale, which is what I told you guys about assuming, which I don't think that I need to tell you guys again. So let's go down to B, and I'm going to work this one for you. Part B, again, the direction said that JK, so that's this one, is congruent to KL, which is this one. So if those are the two sides that are equal, okay, we said JK segment, was congruent to segment KL, then that means the vertex angle is what's between them. And this is just kind of food for thought in case you hear this again. So K is what's between the two, therefore the vertex angle is angle K. Okay, not really too important, just something to know. So if JK is congruent to KL, that means that I can set these two things equal to each other. Well, JK is 4 minus 3x, and that's supposed to be equal to KL, which is 2x minus 1. So if I go ahead and solve this, okay, remember I need to put my x's together. So since I crossed the line, I'm going to do the opposite. So plus 3x. I'm left with 4 equals 5x minus 1. Now I need to get x by itself, so I'm going to move the 1 by doing the opposite. So I get 5x equals 5, and now I divide by 5 as my last step, and I get that x equals 1. So there's the first step. It said to solve for x. Now it says to substitute x in to see what type of a triangle it is. So if I substitute in for KJ, which is 4 minus 3x, that would be 4 minus 3 times x, which is 1. So then 4 minus 3 is just 1. So KJ is 1 centimeter, 1 unit. Then I could do the same thing for KL, which is 2x minus 1. So that would be 2 times 1 minus 1. Well, that's 2 minus 1, which is 1. So we did good because these two sides were supposed to be congruent. So now let's check the last one. The last one is JL. Well, it's just equal to x. Well, x is 1. So that means this one is also 1. So all three sides are equal to 1. That means this triangle is equilateral. We don't know anything about the angles, so it's just equilateral. So now you need to use this example to go up and do the top. Okay, you guys do the best you can on the assignment, and if you need help, make sure that you ask anybody that's available.